What happens inside a black hole? Black holes, these enigmatic regions in space where gravity reigns supreme, pulling in everything that comes too close, even light itself. But what truly happens inside a black hole? Today, we embark on a journey to explore one of the universe's most profound mysteries. Black holes are born from the remnants of massive stars. When such a star exhausts its nuclear fuel, it undergoes a gravitational collapse, compressing its core into an incredibly dense point known as a singularity. Surrounding this singularity is the event horizon, the boundary beyond which nothing can escape the black hole's gravitational pull. Imagine you're an intrepid explorer venturing toward a black hole. As you approach, the gravitational forces begin to distort your perception of space and time. This phenomenon, predicted by Einstein's theory of general relativity, means that time for you would pass differently than for someone observing from a safe distance. Near the event horizon, the difference in gravitational pull between your head and feet becomes so extreme that it stretches your body into a long, thin shape, a process whimsically termed spaghettification. For smaller black holes, this tidal force would tear you apart before you even reach the event horizon. However, in the case of supermassive black holes, like Sagittarius A** at the center of our Milky Way galaxy, you might cross the event horizon intact, as the tidal forces are less extreme at that boundary. Crossing the event horizon is a point of no return. From this boundary onward, all paths lead inexorably to the singularity. The event horizon isn't a physical surface but rather a region in space where the escape velocity exceeds the speed of light. Once crossed, all information and matter are irrevocably drawn inward. At the core lies the singularity, a point where density becomes infinite, and the known laws of physics cease to function. Here, our current understanding reaches its limits, and the concepts of space and time as we know them break down. Not all black holes are the same. Many rotate, dragging the very fabric of spacetime around with them, a phenomenon known as frame dragging. This effect creates an ergosphere, a region outside the event horizon where objects cannot remain stationary. Within the ergosphere, it's theoretically possible for particles to gain energy and escape, a process that could explain some of the high-energy jets observed emanating from black holes. Recent observations have shed light on the dynamic environments surrounding black holes. For instance, the James Webb Space Telescope has provided new insights into the chaotic activities around the supermassive black hole at the center of the Milky Way, revealing continuous flickering and occasional bright flares from the accretion disk, a region known for its turbulence and high-energy interactions. Inside the event horizon, the journey toward the singularity is inevitable. As you fall, the immense gravitational forces stretch and compress you, a process known as tidal forces. The closer you get to the singularity, the more extreme these forces become, ultimately leading to spaghettification, where you're stretched into a long, thin shape. However, some theories propose a different fate. The firewall paradox suggests that, instead of a smooth passage through the event horizon, you might encounter a searing wall of high-energy particles that would incinerate anything attempting to cross. This hypothesis challenges our current understanding and remains a topic of intense debate among physicists. Another enigma is the information paradox. According to quantum mechanics, information about a physical system cannot be destroyed. Yet, if a black hole evaporates over time through Hawking radiation, what happens to the information about everything it has consumed? This conundrum has led to various theories, including the idea that information might be preserved in a holographic form on the event horizon itself. Despite their name, black holes can be some of the universe's most luminous objects. As matter spirals into a black hole, it forms an accretion disk, heating up and emitting intense radiation. In some cases, black holes eject powerful jets of plasma that can extend vast distances into space. For instance, astronomers have observed a supermassive black hole emitting jets stretching 23 million light-years, a length equivalent to aligning 140 Milky Way galaxies side by side. Black holes also play a crucial role in the evolution of galaxies. Their immense gravitational influence can regulate star formation and contribute to the distribution of matter across the cosmos. Understanding these processes is key to unraveling the history and structure of our universe. While much about black holes remains shrouded in mystery, ongoing research and observations continue to peel back the layers of the unknown. As we venture further into the cosmos, we edge closer to comprehending these fascinating phenomena that challenge the very fabric of our understanding. Thank you for joining us on this journey into the heart of a black hole. Don't forget to like, subscribe, and hit the notification bell for more explorations into the wonders of the universe.